Alright, let's look at the homework 15.9, problem number 8. So we have a hemisphere of radius 4, and its density is proportional to its distance from the center of the base. Alright, so let's find its mass. Alright, let's see. Alright, so we want to find its mass. So mass H is going to be equal to, alright, so I'm gonna use spherical coordinates and triple integral here. Alright, so since density is proportional to its distance from the center of the base, so we know that the density here, is proportional, so it's K times, and the distance from the center of the base, that would be the rho in spherical coordinates. Alright, so that's the density. So we're going to put the density, which is K times rho. And the volume element for spherical coordinates is rho squared. So it's going to be rho cubed. And then sine of phi. Then we have a d rho, d theta, d phi. Right? Then since it's a hemisphere with radius 4, so rho is going to go from 0 to 4. Right? And the theta is going to go all the way around, so it's going to be 0 to 2 pi. Right? So phi, it only goes from, since it's a hemisphere, so you're going to go from the top 0 all the way to pi over 2. So it's going to be 0 to pi over 2. Right? Then since this is separable, so go ahead and separate it. Right? So we're going to have, let's do the rho first. I'm going to kick k out. K is just a constant. And then rho, so it's an integral from 0 to 4. Rho cubed, d rho, times theta would be integral from 0 to 2 pi, then d theta, times, then with respect to phi would be 0 to pi over 2, and you have a sine of phi, d phi. Right? So let's evaluate that. So k is just a number, k times, right? Antiderivative rho cubed would be rho to the 4th power over 4. And then going from 0 to 4. And antiderivative 1 with respect to theta is theta. And going from 0 to 2 pi. Times antiderivative sine of phi would be negative cosine of phi. And then going from 0 to pi over 2. Right? So this is going to be equal to k times, right? So plugging 4, so 4 to the 4th power, there's another 4 cancel out, so 4 cubed. So you have a 4 cubed minus 0. Times you have 2 pi, so it's a 2 pi minus 0, so it's multiplied by 2 pi, times, alright, cosine of pi over 2 is 0, minus negative cosine of 0 is 1, so it's going to be plus 1. Right? So this is going to be, let's see, so we have 4 squared is 16, 16 times 4 is 64, times 2 is 128. So 128 pi and the k. Right? So let's type it in. So we have 128 pi k. Right? Let's check the answer. Submit for testing. Alright, it came back and looks like we got part A correctly. Alright, so let's do part B. All right, so part B, we want to find the center of mass of this solid here. All right, so since this object is a hemisphere and it's symmetric, density is also symmetric in the x direction and y direction. So we can simply assume that x bar is going to be 0 and y bar is going to be 0. All right, so we are interested in finding the z bar. Right, so in order to find z bar, we need to find the moment with respect to xy plane. Right, and remember that the definition of this is so this is going to be a triple integral. Right, then it's going to be a z value, so z value. And then we have to do the density, which is k rho. And actually, maybe we should go straight to the spherical coordinates. So I'm going to just do a triple integral. All right. Luckily, the bounds are exactly the same. So I'm going to put 0 to 4, 0 to 2 pi. And 0 to pi over 2, right? All right, so we're going to have to put the, let's see, z value, which is going to be rho cosine of phi, right? And the density is k, so I'm going to put the k in front. And the rho, which is, so make that squared. But the volume element is rho squared, so I have to actually change that to the fourth power. So rho to the fourth power, then sine of theta, phi, then d rho, d theta, d phi. All right. So let's find that. So this is going to be, all right, so let's do the rho. So it's integral from 0 to 4 and the rho to the fourth power, d rho, right? K is kicked out, right? Then next one is theta. So theta goes from 0 to 2 pi as before, d theta. And what's left is from 0 to pi over 2. Then you have a cosine of phi and a sine of phi and d phi. Right? Then find the antiderivative. So it's a k and antiderivative rho. So rho to the fourth and rho to the fifth over 5. And then you're going from 0 to 4. All right, so then here it's going to be, again, theta is going from 0 to 2 pi, so that one's easy. All right, this one is going to be, let's see, derivative of sine is cosine, so I can just use the power rule, sine squared of phi over 2. You can double check derivative of this is going to be put 2 in front, that cancel out, sine of phi, and the derivative of that is cosine of phi, so that's going to, this is the antiderivative. And then you're going from 0 to pi over 2. All right, so this is going to be equal to, so it's going to be k times, and 4 to the fifth power over 5 times 2 pi times, let's see, plug in, let's see, sine of pi over 2 would be 1, so it's a 1/2. And the plug in 0, sine of 0 is 0. So we get that. All right, so you have a 2 and 2 cancel out. So we get that. So this is going to be whatever this number is. It's going to be 4 to the fifth power pi over 5 k. Right? So in order to find the z bar, all we have to do is we have, so we can find a moment with respect to xy plane, divide by its mass, in this case, h. So we have, all right, so it's going to be 128 pi k, and then you have let's say 4 to the 5th pi over 5k. Alright, so we can cancel, let's see, k on top, k on the bottom, pi on top, pi on the on top and bottom. Alright, so let's see. So 128 is 64 times 2, right? So 64 is 4 cubed times 2, right? So we can cancel 4 cubed here, and so that's going to change to 4 squared. And we can cancel with, so it's going to be as, this is 16, and we can cancel with 2, right? So we're going to have 8, right? So we're going to have 8 over 5 as the z bar. So 8 over 5, right? 8 over 5. Alright, so let's type it in. So we get 0, 0, 8 over 5. Right, so let's check the answer. Submit for testing. Alright, it came back and looks like we got this one, part B, correctly. Alright, so let's look at the part C. Alright, for part C, we want to find the moment of inertia of H about the z-axis. Alright, so let's find that. Alright, so in order to find z-axis, so we have to express the distance from the z-axis, which is x squared plus y squared with the square root, but we have we actually want the square of the distance, so we x squared plus y squared, which is the same thing as in spherical coordinates. So x is rho sine of phi cosine of theta. So square that, so it's going to be squared, squared, and squared. Plus y squared would be rho squared sine squared of phi and sine squared of theta, right? And then you can see that this is actually equal to, since cosine squared and sine squared is equal to 1, so you have a rho squared sine squared of phi, right? So we just have to integrate that, right? So you have, let's see, we want to find I sub z is equal to, right, triple integral. Again, the bounds are exactly the same, so we're going to go from 0 to 4, 0 to 2 pi, and 0 to pi over 2. All right, so you have, we have to have, let's see, rho squared sine squared of phi, right? So that's the square distance from the z-axis. Then we have to have a density, so we still have k, right? Then we still have rho, so that's going to be cubed, right? Then we have volume element, which is going to be another rho squared, so it's going to be, this is going to be the 5th power. And the sine of phi, so this is going to be, instead of squared, it's going to be cubed, right? Then we have a d rho, d theta, d phi, right? Then we're going to separate the integral, and we're going to have, so k is kicked out, right? So you have a rho to the 5th, actually, right, I'm going to just integrate it from 0 to 4, and you have a rho to the 5th, d rho, times integral from 0 to 2 pi, and d theta, as usual, and then integral from 0 to pi over 2. Then you have sine of 3 phi d phi. All right. Then we're going to integrate that. All right. So here we have k, just a number, and you have a rho to the 6th power over 6, and going from 0 to 4, right? Then here is an integral which is, it will be theta from 0 to 2 pi. So that one's easy. All right, this one's a tricky one here. So I'm going to rewrite this guy as, all right, I'm going to pull sine of phi from here. All right, so then you have a sine squared of phi. I'm going to write it as a 1 minus cosine squared of phi. Right? And then actually I'm going to put the negative sign outside. So we're going to have a negative sine of phi. Then you have a cosine squared of phi minus 1. Right? Since derivative cosine of phi is negative sine of theta, so I'm going to use a substitution, and you can use a substitution, but I'm going to skip that step. So u equals cosine of phi will let you find the antiderivative, but the antiderivative is going to be cosine cubed of phi over 3 minus cosine of phi. And then you're going from 0 to pi over 2. Alright, so let's plug in. So you have a k, and you have a 4 to the 6th power over 6, and then times 2 pi times, alright, so if you plug in pi over 2, cosine of pi over 2 is 0, and cosine of pi over 2 is 0. But if you plug in, so it's going to be minus, plug in 0, it's going to be 1/3, and minus minus, it's going to be plus, cosine, it's going to be 1. So this is going to be 2/3. Right, so this guy is going to be 2/3. Alright, so we can, let's say, simplify this a little bit, right? So you have, let's see, 2 here. I cancel, that's 3. So what you get is going to be, alright, so you have 3 times 3, so it's 9. So we took care of 3 on the bottom and 3 on the bottom. And then you have, let's say, a big number. So 2 times, I'll just leave it. So how about this? I'm going to write 2 times 4 to the 6th power. And then pi k. Alright. So what's this? So 4 times 4 is 16, right? But you have 6 of those, so you have to multiply by 16 times 16, 36, 96, and another 16. So you have a 256, and we have to multiply another 16. 36 and 30, 12, so 153, and you have a 256, and 6, 9, 0, 4. You have to multiply by 2, so it's going to be 8, 1, 9, 2 over 9 pi k. Right? That's a big number, so let's type it in. Alright, so we got 8192 over 9 pi k. Alright, let's check the answer. Alright, I came back and looks like magically we got the part C correctly. Alright, that's it. I hope that this was clear.